In this last video, we're going to go over problem 4 from the practice side of the guided notes. So we have a vector given, a graphical vector. We want to find component form, find the unit vector, and then the direction angle of the vector. So component form is pretty easy from the graph. I'm just going to show my work to the left of it, but this is for problem 4. All right, I'm starting at initial point of the vector, traveling to terminal point. I'm going left 1, 2, 3, 4. So my horizontal component is -4. And then I'm going up 2. So my vertical component is +2. So part A is complete. I have component form. Now part B, we want the unit vector. So this would be the vector going in the same direction as vector W, but it's only about 1 unit long. So I want to know that. So we start by finding the magnitude. So the magnitude of vector W, we're going to take both components and square them. -4 squared is +16. And 2 squared is 4. When I add those up, I get square root of 20, and I should simplify that using a factor tree. And that would simplify to 2 root 5. So that's the length of this vector, also known as the magnitude. And then to get the unit vector, so we're just going to change the name here to vector u. I'm going to take both components and I'm going to divide by the magnitude. And you could turn that to a decimal if you wanted, and when you go left the amount of the horizontal component and up the amount of the vertical component, it would get you to the end of this unit vector. And we should technically simplify here. 2 goes into 2 once, 2 goes into 2 once, 2 goes into 2 once, and 2 goes into 4 twice. So this simplifies to -2 over square root of 5 and 1 over square root of 5. Okay, now for part C, the direction angle. So I want to know how many degrees it is from our 0 degree point directly to the right to where the vector is. We know it's in quadrant 2, so our answer has to be somewhere between 90 and 180. Since I have a unit vector here, we said in the last video that the horizontal component is actually cosine of the angle, and the vertical component is actually sine of the angle. Now we're going to have to use inverse trigonometry to find this. And remember our restricted domain for inverse trigonometry. This was in 4.7. When we work with sine, it gives us an angle from -90 to +90. So we really don't want to use sine. If we use sine, we're going to have to do some more work to find the angle. It's not going to give us the angle in one shot. Inverse cosine had a restricted domain from 0 to 180. So if I use cosine here, it should give me the angle in one shot. So we're going to say that cosine of theta equals -2 over square root of 5. So my angle is inverse cosine of the ratio -2 over root 5. And then we use a calculator. We make sure that we're in degree mode. I'm going to go to the calculator screen now. I'm in radian mode. So I'm going to switch that. Inverse, sorry, we need a calculator page. inverse cosine of fraction -2 over square root of 5 is 153.435 degrees. So that's my direction angle. 153.435 degrees. And that's part C. So we found component form, we found the unit vector, needed magnitude first in order to calculate that. And by the way, rationalizing is optional in this course, pre-calculus and calculus. If you wanted to rationalize this, you could, but we're just going to leave it unrationalized. And then part C, the direction angle, 153.435. You should try to calculate this with sine theta equals 1 over root 5, just to show yourself that it's not going to give you this direct answer. All right, you can try the other practice problems and check your answers on the filled-in notes.